Let us understand clearly the method of solving problems on Fisher's ideal index method. So, formula and problems on Fisher's ideal method. Fisher's ideal index method. This is one of the categories of weighted index method, and this is the most popular and important the method of index numbers. And the Irving Fisher introduced this method of index numbers, and this is widely used the method of index numbers. And Irving Fisher used the geometric mean of the last pairs and pastures indices to overcome the shortcomings of the both. And Fisher's price index number is given by the geometric mean of last pairs and pastures formula. And the formula to calculate Fisher's ideal method is that P01 price index number for the current year is equal to root of L into P. So root of the last Pierce method into Pastures method. Therefore, root of sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. So this is the formula where we used to calculate indices or index numbers according to Fisher's ideal method. And this is the root of last Pierce uh, last Pierce method into Pash's method. So the Fisher's ideal method is known as ideal index number. Fisher's index number or Fisher's method index number or the method is called as ideal index method because so this method this method which is considered several properties. They are this is known as the best average because geometric mean is used for computation. And this method is based on the current year as well as the base year, and it confirms certain tests of the consistency known as TRT and the FRT factor reversal test and time reversal the test. These two tests which are to be considered and tested in under this the method. And the upward the bias of last year's index and downward bias of patches method index method are balanced to a great extent. So because of these the properties or the characteristic features, so Fisher's index method is called as the ideal index method. So therefore Fisher's ideal method is the most important and widely used the method of index numbers. And here uh, uh, solving problems on Fisher's ideal index method. Now take the first problem. So calculate index number for the year 2017 by taking 2015 as base. So items in the first column. So base year 2015 price quantity, current year 2017 price quantity are given. Means what base year price P0, base year quantity Q0, current year price P1, current year quantity Q1. So therefore having these the data given, we have to compute the index number according to Fisher's ideal the method. So already you know that the formula to calculate Fisher's ideal method is equal to P01 price index number for the current year is equal to root of L into P equals root of sigma p1 q0 by sigma p0 q0 into sigma p1 q1 by sigma p0 q1 into 100. So let us prepare a table showing the values of p1 q0 p0 q0 p1 q1 and p0 q1. So the base year 2015 price as well as the quantity p0  15 8 12 20 30, q0 8 10 5 6 8, and current year 2017 price p1 17 10 15 25 35, and current year quantity q1 10 12 6 8 10. So therefore, so based on the first four the columns, we can calculate another four columns showing p1 q0 p0 q0 and p1 q1 and p0 q1. So now p1 q0 means the product of p1 q0 17 into 8 136, uh, 10 into 10 100, 15 into 5 75, 25 into 6 150, 35 into 8 280. Then p0 q0 uh, 15 into 8 1 120, 10 8 into 10 80, 12 into 5 60, 20 into 6 120, 30 into 8 3 or 240, and then p1 q1 17 into 10 p1 q1 17 into 10 170, 10 into 12 120, 15 into 6 90, 25 into 8 200, 35 into 10 350. So in the last column we have to uh, compute or we have to calculate the product of p0 or q1. So that can be known as p0 q1 15 into 10 150, 8 into 12 96, 12 into 6 72, 20 into 8 160, 30 into 10 300. Now take the sum of sigma p1 p0 q1 778, sigma p1 q1 930, sigma p0 q0 620, and then sigma p1 q0 741. Now substituting these values in the formula. So the formula for calculating indices according to Fisher's method, P01 is equal to root of sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 into 100. Now root of sigma P1 Q0 741 divided by sigma P0 Q0 620 into sigma P1 Q1  930 divided by sigma P0 Q1 778 into 100. So therefore root of 741 divided by 620 is equal to 119.516 into 930 by 778 equals 119.537 into 100. So therefore root of 119.516 into 119.537 is equal to 1.487 into 100. So therefore the root of 1.487 equals into 100 is equal to 119, means 1.19.53. When it is multiplied by 100, then we get 119.53%. So this is what the index number or indices of according to Fisher's method, and it shows that the prices of all the commodities are increased by 19.53% in the current year when compared to the base year. Now take the second problem. So calculate last year's pastures and fishes method of index numbers. So base year price quantity, current year price quantity are given. Now base year price P0, base year quantity Q0, current year price P1, current year quantity Q1, where 1 indicates that current year, 0 indicates that ಬೇಸ್ ಇಯರ್. ಒಂದನ್ನು ನಾವು ಕರೆಂಟ್ ಇಯರ್ ಅಂತ ಕರಿತೀವಿ, ಝೀರೋ ಬೇಸ್ ಇಯರ್ ಅಂತ ಕರಿತೀವಿ. ಪಿ ಮೀನ್ಸ್ ಪ್ರೈಸ್, ಕ್ಯೂ ಸ್ಟ್ಯಾಂಡ್ಸ್ ಫಾರ್ ಕ್ವಾಂಟಿಟಿ. ಲೆಟ್ ಅಸ್ ಪ್ರಿಪೇರ್ ಎ ಟೇಬಲ್ for calculating the values of P1 Q0, P0 Q0, P1 Q1 and P0 Q1. Now take the given data in first four columns. So items are represented in the first column. Now base year price quantity P0, quantity Q0, current year price quantity, current year means P1, quantity Q1. So therefore considering first four columns, then we can calculate another four columns of the values of P1 Q0, P0 Q0, P1 Q1 and P0 Q1. Now P1 Q0 15 P1 current year price into base year quantity, 15 into 25 375, and then 18 into 20 360, 20 into 10 200, 30 into 12 360, 45 into 6 270, and then P0 Q0 base year price, base year quantity, 25 into 12 300, 20 into 15 300, and then 10 into 18 180, 12 into 25 300, and then 6 into 40 240, and then P1 Q1 current year price and current year quantity, 26 means 15 into 26 390, 18 into 22 396, 20 into 12 240, 30 into 15 450, 45 into 7 315, and then uh, P0 Q1. So base year price into current year quantity, 12 into 26 312, 15 into 22 330, 18 into 12 216, 25 into 15 375, 40 into 7 280. Now take the sum of sigma P0 Q0, sigma P0 Q1, sigma P0 Q1 is equal to 1513, sigma P1 Q1 equals 1791, and sigma P0 Q0 1320, and then sigma P1 Q0 is equal to 1565. Now substituting these values in the formula, uh, P01 price index number for the current year is equal to root of sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 P1 Q1 divided by sigma P0 Q1 into 100. This is what sigma P1 Q1. Therefore, root of sigma P1 Q0 1565 divided by sigma P0 Q0 1320 into sigma P1 Q1 1791 divided by sigma p0 q1 1513 into 100. So in the next step, root of 1565 divided by 1320 is equal to 1.185 into 1791 divided by 1513 is equal to 1.183 into 100. So therefore the root of 1.4018 into 100 is equal to 1. When you take square root of 1.4018, so it will come 1.1839 into 100 is equal to 118.398%. So this is what index, the number or indices according to Fisher's ideal index method, and 118.398%. So this shows that the prices of all the commodities in the current year had been increased by 18.1398% in the current year when compared to the last year. So the Fisher's last year's method of index numbers can also be calculated by applying the formula sigma p1 q0 by sigma p0 q0 into 100, and Pasteur's method is equal to sigma p1 q1 by sigma p0 q1 into 100. These the method of calculations were already done in last this session. So you can also calculate here Laspier's method as well as the Fisher's Pasteur's method of index numbers by applying the formula. And in example 3, in this problem, calculate Laspier's, Pasteur's and Fisher's index numbers from the following data. So items in the first column, base year price quantity, current year price quantity are given. So base year price means P0, base year quantity means what, Q0, P andre price, Q andre quantity, 1 is equal to current year, Q is equal to base year. So therefore P0 40 75 90 30 25, Q0 480 600 5 540 210 200, and then current year quantity, current year price P1 15 10 8 10 15, current year quantity means Q1 525, um, and then 300 means quantity ಕೊಟ್ಟಿದ್ದಾನೆ ಇಲ್ಲಿ. Quantity means what, value. So value means it includes P0 Q0. uh, uh, it, so it should be kept in mind that when value or quantity are given, base year quantity means what, base year P0 Q0, it includes P0 Q0. Then it is to be divided by P0, then you will get Q0. And in the current year quantity or value, it includes P1 Q1. Then when you divide current year quantity or the total or the value by given price, then you will get current year quantity. So it is to be done here in the next the table. So base year price P0 are given 40 20 75 90 30 25, and then P0 Q0 or value or quantity 480 600 540 210 200, and then current year quantity Q1 15 10 8 or 10 15, current year quantity current year quantity 525 divided by 15, then price. Okay, this is quantity, current year quantity, not price. So current year quantity q1 is equal to 15, 10, 8, 10, 15, and then current year quantity or value that includes p1 q1 525, 300, 240, 300, 180. So therefore p1 q1 current year value divided by current year quantity, then you will get current year price. P1 is equal to P1 Q1 divided by Q1. 525 divided by 15 is equal to 35. 300 by 10 is equal to 30. 240 by 8 is equal to 30. 300 by 10 is equal to 30. 180 by 15 is equal to 12. Then P0 Q0 divided by P0, then you will get Q0. So therefore when you divide P0 Q0 base year value and its base year price, then you will get current base year the quantity, means Q0 is equal to P0 Q0 divided by P0. 480 by 40 is equal to 12. 600 by 75 is equal to 8. 540 by 90 is equal to 6. 210 by 30 is equal to 7. 200 by 25 equals 8. Now P1 Q0. P1 Q0 that can also be calculated by taking into account P1 Q0, the column 35 into 12 420, 30 into 8 240, 30 into 6 180, 30 into 7 210, 12 into 8 96. Then P1, then P0 Q1. So P0 here P0 Q0, P1 Q1 are given, then P1 Q0 already calculated, then the next the requirement is P0 Q1. So that can be calculated as P0 Q1 40 into 15 600, 75 into 10 750, 90 into 8 720, 30 into 10 300, 25 into 15 375. Therefore the total of all these sigma p0 q1 2745, sigma p1 q0 1146, and then sigma p1 q1 already given in the problem itself 1545, and sigma p0 q0 2030. So therefore by substituting these values in the formula, then you will get indices or index numbers according to Fisher's ideal index method. So P01 price index number for the current year is equal to root of sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 into 100. So therefore root of sigma P1 Q0 1146 by sigma P0 Q0 2030 into sigma P1 Q1. This is Q1 current year price and current year quantity 1545 divided by sigma P0 Q1 2745 into 100. So therefore root of 1146 divided by 2030, then you will get 0.5645 into 1545 divided by 2745 is equal to 0.5628 into 100. So therefore root of of 0.5645 into 0.5628 is equal to 0.3177 into 100. Therefore, the square root of 0.3177 is equal to 0.5636 into 100. So, therefore, 0.5636 into 100 is equal to 56.365%. This is what the indices or index numbers according to Fisher's ideal index method. So therefore this is what the calculation, the method of calculating indices or index numbers according to Fisher's ideal index method. And you can also calculate here the last pairs and Pasteur's method of index numbers by applying the formula. Last pairs method is equal to sigma p1 q0 by sigma p0 q0 into 100, and Pasteur's method is equal to sigma p1 q1 divided by sigma p0 q1 into 100. So this is what the way in which we are going to calculate index numbers according to Fisher's ideal index method.